Okay, so good morning everyone again. So yes, Marcel mentioned, so now I'm gonna present some work that was mostly done by a master's student I had to Eindhoven. So yes, first a little bit of background. So the whole idea was we have these block-based environments and we think that these block-based environments are better and are good for end users, especially if we think about end users as people that do not have any background in computer science, but really domain experts. When we look at the automotive domain, so there are two big systems that we have nowadays, which are advanced driving assistance systems and in-vehicle information systems. So these are two of the big systems that are nowadays shipped in those cars. So for instance, an example of an ADAS is, for instance, a lane departure warning system. So when you are driving and then the car notices that, oops, something is getting in a wrong direction, that then you feel like the steering wheel is like trying to put you back in the right track. And then an example of IVs, it's more like vehicle status, navigation, multimedia, and all these type of things. Also communication. So there are many things that are happening nowadays in vehicles. So then somehow this needs to be programmed, okay? So one of the options and the most used is to use rule-based systems. And the idea of using these rule-based systems, it's mostly to incorporate human knowledge using a set of if-then rules. So that's the whole idea. So then someone needs to define those if-else statements so that we can incorporate this human knowledge into the system. So this is how it's traditionally implemented. And then there is also the thing that, well, we need to adapt those interactions because we cannot just define this like up front and say, okay, this is how it's going to run forever. But there needs to be some adaptations depending on the environment, right? So when we are driving, there are many things happening in that moment. So somehow the system needs to adapt depending on the conditions. Maybe now it's freezing, or maybe I'm just getting sleepy. So all these conditions are happening when we are driving. So then this is a brief summary where we have a domain expert, and this domain expert needs to define those rules for this system. So I'm not going to talk about all the issues that we identified and also the ones that we described in the paper, but I want to focus mostly on this one. So we noticed that the syntax might be a little bit intimidating for end users. So I think we are all here programmers, so this might not be intimidating, but if you have never seen this in your life, this will be like, okay, why there are those red things, red letters, words there? What about those quotes everywhere? You also have these square brackets. So if you are not technical person, then it will be like, I don't know what is happening here. This is just magic. So then we also have another problem, and is that the rules grow quickly in number, and the complexity of decision logic also increases. So if we take a very tiny piece of code, then okay, maybe you can make something out of it. But then if you start adding more and more rules, this will just become something that an end user cannot deal with. So they are very powerful. So these type of systems are extremely powerful. You can define many things, but they are in a way technical. So we thought, okay, how can we define a language or describe a language to provide non-technical users with a user-friendly mechanism to specify executable rules for HMI interaction adaptation? So how can we define this language or this additional level of abstraction to specify this type of rules? So this is what we called AHSL. So here we have the domain expert as the entry point where this domain expert needs to define that specification. So that specification, as we define it, is a set of assignment operators where we just assign this value under these conditions. So this is the main approach that we followed. And here we define this small DSL to leverage on top of a tool I developed also called Kogi, in which we take the specification of the language, and from that specification we are capable of generating the block-based editor that you see on the bottom part, but also the textual editor. So all these implementations are made using Rascal. So basically this enables us to take existing languages and then just make a little very tiny modifications, and then we can get a block-based environment for free. And then once we have this already allows us to give the user either a traditional DSL, a textual DSL, where it's going to be closer to the domain expert, or we can also offer the same language in a way of a block-based environment. And after running this specification, so we compile this to more traditional rule engines where we can run those specifications. So this is a very tiny example of things that we can do. So we conducted a domain analysis to identify the different types of things that are happening in the automotive domain. And on the left-hand side of the screen, we can see the specification of some of those rules. So for instance, we can say that if the traffic risk will be high when there is a vulnerable road user, and by default we say that it's going to be low, or we can encode something like, okay, the driving demand will be high if the intersection type is a roundabout, okay? Otherwise, it's going to be low. So we can encode all these different types of situations. So to conclude, what we wanted to achieve with this type of system is that instead of the domain experts learning some particular programming language, Java, C++, or something like that, to define a domain-specific language that allows them to define these rules in a more concise way. Here, we wanted also to, again, take advantage of block-based languages because they are easier for users in different ways. One of the benefits is also that when you have a textual language, well, you don't have this palette of, okay, which language constructs are available in the language. So in the block-based environment, you can just see what's available in the language, and then you can just start playing around with those things. So this is less intimidating for users. This is some ideas of future work that we also presented, so to extend it to other applications. So now we were only focused on this suppressing of messages, onboard messages. Also to evaluate the usability. So again, we now create these block-based environments, but is it really better for end users? We conducted a small prototype and then with non-experts, and it was promising, but is it really good for people in industry really working in the automotive domain? So those are open questions. And also we use only rules as an engine to run those rules, so to explore maybe with other options. I think I went a bit over time, but this is the brief summary of the paper.
Thank you. So let's maybe start with the first part. So what did you hear? What would you say is the summary of this project or the paper? Just in a very objective, neutral sense. What is this about? And maybe if there's online some, can you check? There's some, or maybe Tom also. Robert.
So it's about DSL, domain-specific language, for actually a particular domain. The paper is really clear about the application domain of that DSL, and it claims that by using this DSL, the developers or the people working with the systems could be more concise, and not only by using the language, but also by the tools that support that language.
Thank you.
So what I found interesting from what you showed is the fact that so the end goal is this Blockly based environment, but to get there you use a DSL as sort of in between, right? So you come up with the abstractions for this particular domain and express the abstractions in the definition of a DSL, and then you get the programming environment for free from the DSL definition. That's like a two-step process. I immediately have a question related to that, if I may. So I wonder, like, which of the two is like expected to give the main benefit to the end users, right? Is it that hiring the level of abstraction to a DSL, textual DSL, or is it more the visual Blockly aspect?
So that's actually a very good question, and I never thought about it in that way. So our main approach was focused on using the blocks, and we assumed that the blocks, the visual representation was going to be just like better and easier for the end user. But also, yeah, by analyzing the problem and defining these language constructs in the DSL, well, we are already kind of helping them, because then they can really focus on the domain concepts and not really just in any GPL writing all the code that you have to write, but this is really focused on the domain. So I think both have like, yeah, the same goal. I would assume that also because what I mentioned, I mean, if we think about the textual DSL as just something that, well, you have a text editor and then you go, well, then I think the block-based will be better, because in the block-based environment, you can see this palette with all the different language constructs. Maybe you can also give different meanings to the colors, so to give really semantics to the different aspects of the language, not just like, well, these are random colors at the moment, but maybe you can also add more meaning to the different aspects that we can see in the block-based one.
So thank you. Well, I also heard things about language transformation or execution, like having a higher level language that's more suitable for the domain and making it somehow work on a lower level execution platform. So let's switch to the second part, maybe merge them. So the I like, I wish part. So what did you like about the presentation, about the idea, how this mechanism works, and what would you wish to see improved? Maybe you have an idea. Whatever you can think of.
So what I liked was the the very thorough examination of the related work, the projects that you looked at, and the way you derived your sort of requirements, the things you would like to address or solve. And what I also liked was just seeing the DSL, the language, and also the tool and its support just really next to each other. And then I was wondering, because usually people talk about their language and tools are often a second thought, if at all, right? I was wondering, just from the end user's point of view, what is more important, the language or the tool support that is based on the language? And then if you always start out with the co-design of the UI or the tools and the language, how you would proceed out. There is one part or the other that dominates the design. This was a question that came up.
So shall I answer the question right away? Yeah. So that's a good comment, especially like whether it's more important the language or the tool support that we offer for the language. So I think we cannot just say we should focus on making the language and then let's forget about the tools. But I think they really go hand in hand. And I think that's also why my focus here was mostly on, okay, let's assume that we have the DSL. And then coming back to Thomas' question, that's why I never like made this process of thinking like, by just making the textual DSL, well, we are already identifying the different concepts, and then the tools that we use to interact with that language, I think it's essential, and I think there is also one of the limitations of this work is that we, together with the student, we were thinking about, okay, this is what we assume domain experts want to do or want to have. But this might not be true, or it might be true, but then it requires like constant feedback from the end users and the domain experts to, okay, yeah, well, if you are building a car, maybe this is not the setup for building a car. Maybe they're also interacting with, I don't know, X number of tools where they are modeling different aspects of the different components of the car. So how these tools can be integrated into the existing pipeline. And this is also one of the extension points that we want to take for this project, to try to integrate experts in the domain, really building these systems to see and understand how those domains work.
Thank you. Any more comments on what you liked, what you wish to see improved?
So in the paper, there's quite a bit of attention to the assignment concept, and I find that perhaps a bit difficult to square with the also rule-based approach, right? So you want to be declarative, and then there's a notion of state or assignment apparently. And I wonder, is that whether that's something that is inherent to the target language? Or would there be ways of perhaps having a fully declarative specification that still targets the same language?
Yes, so I think that's a very good question, and basically as you described, that was the approach that we followed. So we kind of reverse engineered like how rule-based systems were working, and we tried to say like, okay, we conduct this domain analysis where we can identify the different aspects. So let's try to see how we can match these two together, but really tied together. So I mean, at this moment, well, we are just generating the rules language, the rules language, but we didn't like isolate from there and saying like, okay, let's try to do it in a more generic way that we are not dependent on this one. But here you can clearly see that it has a direct influence on the language. So that's something also that it should be revisited for a next iteration of the current work.
Can we see the Discord for a moment? We have one more comment from Tom. There's Tom. So, yeah, go ahead.
All right, yeah. So in terms of what I wished for, what I liked, I think there's two aspects that I would like to briefly touch upon. One is about the language design, which I think you also discussed in the paper itself. I hope I don't duplicate content right now. We were briefly disconnected remotely.
No, that's fine. But now you're gone.
It's fine. Now it's not fine.
Okay.
Manner.
I think we lost.
Can you start? Can you start over, please? We just lost a couple of seconds.
All right, all right. Yeah, it's now stable again. Yeah.
Yes.
Okay, excellent. So in terms of the language design, we had these two interesting choices of removing all syntax, which makes it somewhat difficult to be explicit about more complicated Boolean.
I think both pictures froze, so it's probably our side.
Slowly coming back. Yeah, he's back.
All right.
Oh, we
yeah,
have
here it's
we have
quite
time.
nice. Niemand, I can.
Try again.
Okay, excellent. All right. So yeah, in terms of the language design, I mean, it was really interesting. That brings me to my second point, that in the study, you actually tested with people that have programming experience, right? And exclusively even. One question that I would have, I'd be curious about if that was an intentional choice to test with people that have programming experience or limitation. Since that obviously also kind of taints their impression, as you already point out in the paper, right? And in terms of the study design, I was also a bit curious about how long people actually use the block-based editor, since they seem to have very little exposure. since you only had a single subtask and everything else was done in text, right?
Yes. So, so the first question about if this was intentional, all the users that tested the tool, if it was intentional. So no, it was not intentional. And actually, as we reported in the paper, we made a first run with a non-technical person. And I think the complexity of everything that was around running the tool, like you need to have Rascal there, you need also to generate the blocks. So I think this already added some overhead at the moment of conducting the study. So then that's why we said, okay, this prototype as is now, it's not ready to be used by a really non-technical person, but it's more not about the application itself, but it was about the whole infrastructure around the application. So that was one of the limitations that we noticed at that moment. So then, yeah, that was the main reason why we decided to, okay, let's see how this goes with people with more technical experience, because yeah, I mean they are more familiar to seeing this type of environments. So I think that's why we decided to continue that path, at least to get some feedback also from experienced developers, maybe not really familiar with this domain, but experienced in the sense of they are not afraid of seeing the Eclipse or the Visual Studio Code window. So that was basically. And what was the second question? I forgot that one.
The question was how much exposure people had to the block-based environment, if you think sufficed to get a good impression.
Yes. So I think the common answer is that sometimes when you show these block-based environments to experienced people, they're like, the feelings are more like, well, they are either meant for children, or if I know how to type it in text, well, maybe I don't want to do it by dragging and dropping blocks. So I found that was a limitation, and one of the users explicitly mentioned this, like, yeah, well, the blocks are nice, but no, to be honest, I just prefer to just type in everything. So I think that's also something that, well, it must be taken into account, especially as an extension, to really understand what are the limitations, but what are also the real opportunities that block-based environments open, and in which domains and what type of languages. So I think it really requires a more extensive study of the usage of these type of languages.
Okay, fair. Thank you.
Okay. Well, I have a question about, well, you started with showing us some traditional code, and that is really hard to understand, maybe even for programmers. And what do you think about seriousness of the domain? If you want to come into this domain, program an automotive device, and it looks more and more easy, colorful, with the puzzle metaphor, and you want to program the brakes and the acceleration and stuff, and you think about, okay, do we have to also come up with another form of, well, I don't know, teaching? If this is really so simple to program, do we miss something that comes for free with the more traditional, complicated language part that you had to do anyway? Okay, I program some hardware, or you know what I mean?
Yeah. That's a good comment. I cannot talk about the automotive domain, but I can talk a little bit about, because this was also the whole Coggy stuff started because I was working at Canon in the Netherlands, and they were building all these big machines to print like these huge posters. And then I was like, hey, well, I have this nice block-based environment. And then, well, the first time they were like, that looks interesting. But then the second time we're like, yeah, well, but that doesn't look very professional. It looks too colorful. I don't think our engineers would like those kind of visuals or representations. And I think that's one of the main issues that I think this type of more friendly or colorful environments have. But I think something that can be explored is that they don't really need to be that colorful, right? So if the colorfulness of the environment is the problem, you can also try to make it like more professional, depending on what you call professional. But at least for a more industrial setup, I think that's something that really shocks, like, yeah, but this is what my child is playing with. I'm not gonna be doing that. I mean, I went to uni, I have all these years of experience. But I think also, in a way, I mean, when we use Python, I mean, it's way easier than using assembly. And we are still, many of us are using Python. So I think it's the same kind of discussion, but I think these type of environments, they have a lot of potential and also mixed with other notations. So it doesn't have to be just like blocks, text. It can be something in between. We also have node-based editors. Maybe node-based editors can be just like mixed with block-based editors. And then still, you need to have some text, because even if it's a visual representation, well, you still have some text in there. So I think that also comes back to the keynote we had this morning, where, yeah, I mean, the visual programming is also text. So it's more like how we can enhance these abstractions to make it easier to show like, okay, well, with this block, you can do something like that.
Thank you. Let's thank the speaker again.